We are upgrading our solar panels and adding battery storage. To size the system, our sales guy needed to know how much energy we use. It's trickier to figure out than you think. Our kids helped us to visualize it. Actually, it was their colored blocks. You have to start with understanding how energy flows between your household use, your solar panels, and the grid. Let's picture how it works with three scenarios. First, with no solar panels, then with solar panels only, and finally with solar panels and battery storage. First, no solar panels. These orange blocks are your household uses: lights, computers, appliances, whatever. This is energy that you consume. These dark blue blocks are energy supplied by the grid. And these yellow blocks are units of electricity generated by your solar panels. We can look at different time slices: by the hour, over a day, a month, or a whole year. Let's break time into morning, afternoon, and evening. We can also separate into weekdays and weekends, and winters versus summers. So, one fine summer Saturday morning, you make coffee and start the washing machine. In the morning, you use 3 units of electricity, or 3 orange blocks. Since in this scenario you have no solar panels, you buy this electricity from the grid. Then in the afternoon, you turn on the air conditioner. For the afternoon, you use 4 orange blocks. Then in the evening, you turn off the air conditioner but turn on the lights. Your usage goes down to 3 blocks that you buy. How much electricity did you use all day? Well, in fact, you don't measure the electricity from each of your appliances directly. All you can measure is what the meter tells you: transmission happening with the grid. You can look up your usage online and the power company will tell you. You bought 10 blue blocks of energy. So that's how much you must have used. Next, let's say you have solar panels but no battery. That's the system we bought in 2007. On our fine summer Saturday morning, we make coffee and start the washing machine. We use 3 orange blocks of energy. But the solar panels kick in, producing 1 block of energy in the morning. We only need to buy 2 from the grid. That's called power import. In the afternoon, our solar panels are really cooking. They produce 6 blocks of electricity. With the air conditioner, we're using 4. So we get to sell 2 blocks to the grid. That's called power export. Then, in the evening, our consumption goes back down to 3 blocks. The sun is not shining, so we have to import this power. Over the course of the day, our solar panels produce 7 units of electricity. We used 5 and exported 2 units to the grid. Since solar panels produce power unevenly over the day, we still had to buy 5 blocks from the grid as imports. How can we tell how much power we used that day? Remember, we cannot count the orange blocks directly. We can count the number of blue blocks we bought from the grid and the number of yellow blocks we sold to the grid. The power company meters this, and you can look it up on your billing statement. And if we look at our inverter, we can see how much power it generated that day. That's the total number of yellow blocks. So how much did we use? It's the number of blue blocks we bought plus the number of yellow blocks we used And that's the total number of yellow blocks we produced minus what we sold to the power company. 10 blocks. Now, one of our objectives here is to tally up how much energy we use over the course of a year. We can use the same method. Our bill tells us how much total electricity we bought from the grid for the year. That's the blue blocks. And how much we sold to the grid. That's the yellow blocks that we exported. How much electricity did our panels produce over the course of the year? That's the total number of yellow blocks. Our system doesn't tell us this. But what it does tell us is the total lifetime production. If we divide that number by the number of years we've had it, that's a decent estimate of how much it produces per year. So, we have total yellow blocks minus yellow blocks sold to the grid, then plus blue blocks bought from the grid. That's our orange blocks, the amount of energy we used for a year. This is the starting point for sizing our new system. Before we consider how battery storage comes in, let's look at our system on a summer weekday. You make coffee, take a hot shower powered by an electric water heater, and fire up the computer. You use 3 blocks of energy. The solar panels give you 1, so you import 2. In the afternoon, your solar panels generate 6 blocks of power. You're away at work, so you put the air conditioner on minimum. You only consume 1 block in the afternoon, and you get to sell 5 to the grid. Then, in the evening, the sun goes down, so you still have to buy 3 blue blocks. On a weekday, your panels produce 7 yellow blocks, but you only use 2. So you bought 5 units from the grid when your solar panels were not producing, and you got paid for 5 units that your panels generated when you didn't need it. Does that even out in money paid between you and the power company? Well, that all depends on rate schedules like time of use and net energy metering. That's a subject for another explainer. Here, we're just talking about energy usage, which is measured in kilowatt hours. Finally, what does battery storage do for you? Battery storage is these green blocks. What they do is hang on to electricity your panels generate. So, as your system generates yellow blocks throughout the day, you don't have to either use them or else sell them to the grid immediately. You can store that energy to use later. Let's say they installed the system on Friday, so you wake up Saturday with solar panels and an empty battery. You start the coffee and washing machine and use 3 orange blocks of energy. Your solar panels produce 1 yellow block, so you buy 2 blue blocks from the grid. Then, in the afternoon, with the air conditioner running, you use 4 units. Your panels produce 6. But instead of selling the extra to the grid, you store them in the battery. In the evening, you consume 3 blocks. You take back the 2 from the battery and only have to buy 1 block from the grid. So with this system, over the course of the day, you only buy 3 units from the grid instead of 5 if you didn't have the battery. All of the 7 units your panels produced cover your own consumption instead of sending power to the grid when you weren't using it, then buying it back later. Does that work out to a financial benefit over the course of a day? It all depends on whether the grid will buy back yellow blocks from you at the same price they sell you the blue blocks. It depends on time of day import and export rates, but most rate schedules do not pay back equally, so you're ahead with the battery for the day. The deal sweetens on weekdays once you charge up your battery and save it overnight. Suppose you start with an empty battery Monday morning. You get up and use 3 orange blocks. Your panels give you 1 yellow block, and you buy 2 units from the grid. In the afternoon, while your panels are producing 6 yellow blocks, you use 1 and store the other 5. In the evening, you use 3 orange blocks. Instead of buying this from the grid, you withdraw these from the battery, leaving 2 for the next day. You have bought 2 blue blocks worth of energy for Monday. Tuesday morning, your 3 orange blocks are covered by 1 yellow block from the panels and 2 from the battery. In the afternoon, your 6 blocks of solar production again charge your batteries to 5 while you use 1. In the evening, you use 3 from the battery, again leaving 2 for Wednesday. After you charged up on Monday, then on Tuesday and for the rest of the week, you end up paying nothing to the power company. On a weekday, all of your 7 orange blocks of consumption are covered by your yellow blocks of production, which was smoothed out by the battery so you could use that power when you needed it. So, you save money on monthly or annual energy bills, but a solar power system with battery storage costs something up front. A lot, actually. What's the payback time? Well, again, that depends on the energy rates, time of use plans, battery capacity, seasonal differences in generation, and other stuff. It's pretty complicated. Our sales guy has algorithms to figure it all out and make recommendations. What he needed to know was, how much electricity do we actually use? Our kids' blocks helped us to work that out, and we hope this illustration helps you.